As a V specialist within EMC, I often get asked questions around the ability to actually monitor and manage the storage infrastructure from within the virtualization space. A recent query related to this asked whether within vCenter you could detect and then report on a storage port level failure. This led into a discussion around the flexibility that is provided with vCenter alarms. This demonstration, it will focus in on the creation of an alarm that then can be utilized to extend your existing monitoring services to report on a port level failure. To help demonstrate the effectiveness of custom alarms within vCenter, we'll be utilizing our facilities within the Sydney Solution Centre. This comprises a Cisco UCS implementation of one chassis fully populated with 6 blades connected to the network via 2 6120 FIP fabric interconnects. Each interconnect is connected back to the chassis via 4 FCOE connections. Within vCenter, you'll see when we select a host that under the configuration tab that we have 2 HBAs. We have already presented source from our Clarion 6 4480 within the Solution Centre storage to the HBAs, which we can see further details when we access the EMC storage tab, which is provided via the EMC free plugin for vCenter VSI. So let's have a look at how vCenter by default treats any connectivity loss between the actual physical host and the storage. To simulate this situation, through UCS Manager, we're going to disable a single path between the chassis and the interconnect. This will result in any blade utilizing that path in losing 50% of its network and storage connectivity. So if we go into vCenter, we know that we've actually triggered this situation, but we have no immediately visible indicator that a problem exists. Yet if we select a host that we know was utilizing that path and then look at the paths, we can see that they are now reported as dead. So a problem definitely exists within the environment, but again, we've had to drill fairly deep to try and find that problem. You can see that no actual alarms have been raised, but there are corresponding events that do give detail in relation to the impacted ports and LUNs that the actual disabling of the path have actually caused. Again, within the VSI tool, we can also see that the amount of active paths against the actual available paths has been reduced. Within the hardware status tab, where general hardware health is reported, operation has still been reported as being in a normal state. It gives no indication of a problem existing with external storage. So I'm a bit old school when it comes to looking after the environment. And I like to not only have something that leverages my monitoring environment, but also gives me some visual. So to do that, we're going to create some alarms. First, we select the area where we want those alarms defined. And at this stage, it's the top level root folder that allows the alarms to be defined and be actually applied to all hosts underneath. We're going to create 2 alarms. The first one focusing on just the degraded storage path, so it'll report a single port failure. We need to, from within the alarm type, we need to set our target as a host, and we're going to be monitoring specific events. We now need to define the event that we want to monitor, and as you can see within the while we're creating this alarm, there are an extensive array of events available. So I highly encourage anyone to have a look through, and you'll find events to track almost any condition that you want. So we've in this a degraded storage path redundancy is the event that we're tracking. Just to add a little bit of value added to this alarm, we're also going to specify a default command to run. This is a little executable that we wrote that it will raise an event log based on the event ID that you specify within the command line, and utilizes environment variables that are defined within the shell that the actual executable will be executed in when the alarm is raised, containing all the details about the actual error condition that has triggered the alarm. So decoded storage path redundancy will cover as a port level failure. What we also want to look at is something a little bit stronger that actually shows when overall redundancy has been lost to a path. So when we've lost, if we've got 2 ports, that we've lost actually one of those ports. So this, again, it'll be just a following the same process. And you'll see it's a lost storage path redundancy will be the event that we'll look to monitor. So again, we're focusing on the host and monitoring for a specific event. The trigger in this case is the lost storage path redundancy that we'll be tracking. And what we'll do is create a custom command that specifies a different event ID when added to the event log of the local hosting machine. Event logs entries are good if you're utilizing monitoring solutions such as SCOM, where it's very simple to create a SCOM pack to that will draw particular event IDs to raise tickets or alerts accordingly. What you'll see is we've created these alarms at the top level. What happens is those alarms are then propagated down the actual tree within vCenter. So if once completed that, you'll see that if we click down the tree and we can actually select a specific host, that we'll still see those actual alarms are present. Though you can actually view those alarms anywhere down the tree, they are only editable at the original location where they were created. So so as you can see here, we can select the host. They are there, but they are a reader-only alarms, although they are still active. And I think we're ready to go to see how we can actually see these alarms in action. So we've now created the alarms. So let's see how that's changed our client-based visibility to these issues. So as with before, we'll utilize UCS Manager to disable one of the ports connecting between the chassis and the fabric interconnect. This will trigger the port level failure as before. So if we flip over to the vCenter client, what we'll see and focus in on the host, whereas before we had to delve into the actual configuration section, now all of a sudden we've got a visual representation at the icon of the impacted hosts, as well as within the alarm section, we now have 2 triggered alarms. If we have a look at within the events area within the host, we can also see that 2 new entries have added in that correspond to the alarms that have been triggered. Again, looking out under configuration and look under the storage adapter, we can see, as with before, that we have dead paths, but whereas before we had to dig in to actually find those conditions reported and have a look at the event, we now actually have alarms corresponding with that. The other side is obviously with our custom command that we specified, we've also got event log entries that have been added in under the description. We've utilized the environment variables to give us a rich source of information, including the ports that have failed and the impacted LUNs that are associated with those ports. Alarms, we've only just touched on the easy level of alarms. They can go a lot deeper than that, and I encourage you to have a look. And don't forget, VSI rocks, and it is free.